Welcome all of you for today's live session. Welcome all of you for today's live session. We will start today's session. This is the last live session for this Economic Operations and Control of Power System NPTEL course. And this will be the summary of the entire course. And I thought the best way to do this session would be to take all the questions that we have discussed in all the weeks. We will discuss all those questions again so that you can have in one presentation you can get all the questions, and this PPT you can refer for prepare for your exam, which is in the upcoming week. Let us start. We will not, because this course is there are so many topics and we cannot cover all of them in one session, and already summary has been, all the topics which were discussed have been summarized in the lectures also. We will make this more relevant for you by discussing all the week's question again in this session. If you have any question, you can always ask any kind of doubt that you have. You can, so that you will not make any mistake in the exams. So you already know this, that the live sessions are all recorded and they are uploaded. The link is uploaded along with the PDF which is used for the lectures, that is already available on the portal, and you can go through them before your exams. We will start with the questions. So let us start with the first question. So combine all the questions for the entire 12 weeks. There are around nearly 100 questions which I have combined them, clubbed them together here. So let us start. So the first question is, which of the following power generation technologies is considered the most efficient in terms of heat rate? Which one do you think is the correct answer for this? In terms of heat rate, which one is the most efficient? If we talk about heat rate, then these two are not even in the picture because they don't have a heat rate. They're the renewable energy power plants. They are either based upon, they depend upon the input, which is either solar irradiance or insolation, or solar PV, or the wind speed or wind velocity. In case of wind, then we have fuel biomass. We have hydro. Here in hydroelectric power plant, we have the flow rate, the water flow rate, and also it is governed by the head of the storage or the dam. Depend upon the difference between this above after bay and fore bay. Difference of height between after bay and fore bay. So that governs the generation from the hydroelectric power plant. And so out of among these two, thermal and nuclear, the nuclear is more efficient in terms of heat rate. It has a higher efficiency. The answer in this case would be nuclear. Let us move to the second question. The second question is, what is the primary purpose of Green Energy Corridor project in India? You already know that, first of all, green energy. So just by green energy, you can say it is related to renewables. And because we know that for large solar and or wind farms. Okay. They are located because they are large solar and these renewable plants. They are located in remote places because they require a huge amount of land, which is available only in the remote places, not in the city area or the urban area, where the land is very restricted. Not we don't have that much land, and also they depend upon the geography. First is the land requirement, then second one is the geography. They are dependent upon the location specific. The quality of the wind or wind or solar resource depend upon the geography. Certain states would be having higher potential for solar and wind generation. For example, you can say the coastal belt that is having more potential of wind generation. Similarly, solar, we have Ladakh, we have Rajasthan, in Gujarat, Madhya Pradesh. These are the area where solar power is more. The potential for solar is more. We uh, we build plant in these areas because they are in remote area, we need to connect them to the grid, and they require a transmission line because we are generating a very huge amount of these farms now. One solar farm which is being built is in Khadwa, Rajasthan. It is 4 gigawatt. Its rated capacity is 4 gigawatt peak. It will be generating such a huge amount of power, and for transferring this power from that location to the grid, we require corridor, like transmission corridor. We require transmission network, transmission line. So we call this network or this corridor, transmission line, parallel lines, or corridor as the green energy corridor because it is carrying the green energy which is generated by the renewables. We call them green energy corridor. So for integration, for evacuation of this renewable energy generation, this dedicated corridor is being created wherever the potential areas are there. So specifically for evacuating this renewable power, this project was launched. So what would be the answer? The answer would be to promote development and integration of renewable energy resources, right? So this is dedicated only for renewable energy resources. Third one, which of the following is a good attribute of it is a good attribute of a good power system? Yeah, in good power system, we want it to be reliable. We want it to be safe, sustainable, cost effective. So we can say economical. So here we can say secure. If we talk about economics, then we want the losses to be less, right? We want minimum losses. Reliable, we want sufficient generation and transmission capacity. Should be able to handle contingency. Reliable and secure operation. Yeah, this is already discussed. The good power system would be rather it would be decentralized or distributed, I would say. Not everything will be centralized. The attribute for a good power system is to have a reliable and secure operation. We don't want limited capacity. Capacity should be sufficient to integrate all the renewable energy which is generated. And we want losses to be minimum. Fourth one, what are the primary functions of the automatic generation control in power system? Do we know that this is the primary control, primary frequency response? We have secondary as well as tertiary also. Yes, so to regulate the power output of generator to match the load demand, yes, this is correct. To optimize economic dispatch of power generation resources, to ensure stability and reliability of grid during disturbances, to monitor and control the voltage levels of the grid. To optimize the economic dispatch of power, this is part of this is economic dispatch. We already discussed, right? This comes under power system stability. To monitor and control the voltage and frequency levels of the grid. This will come in power system controls and dynamics. Here we are not talking about voltage. AGC is not concerned about voltage. It is concerned only about it deals with the frequency component, not voltage. So this option is not correct. Only option which is left is to regulate the power output of generation to match the demand. So this is done by the Drup characteristics. So these generators are operating in parallel, and because of these Drup characteristics, they are able to share load. When they have same no load frequency and same group, they will share the power in proportion to their rating or installed capacity. In the context of optimization problems, what are the Karush-Kuhn-Tucker conditions used for? We know that this is a standard optimization problem, minimize f of x subject to g of x is equals to 0 and h of x is less than equals to 0. This is our standard optimization framework. We have to, and we have discussed that to, so this is a constrained optimization problem. And if we remove these two constraints, then it becomes an unconstrained optimization problem. Simply, this is an unconstrained. If we have only this part. When we have these constraints also included in the problem, then it becomes a constraint optimization problem, and we can convert this constraint optimization problem into unconstrained optimization problem using the Lagrange multiplier. Concept of Lagrange multiplier. It is a function of the decision variable which are originally there in the constraint optimization problem, as well as there is one more decision variable corresponding to equality as well as inequality constraint. Let us first do it only for equality constraint. If we consider that only gx is there, which is the equality constraint, then this Lagrange function will be fx plus lambda times g of x. Now there are no constraints, and it becomes an unconstrained optimization problem. And we can simply differentiate it with respect to x and with respect to lambda, and we will get our stationary point, and we can get the solution. We can solve for lambda as well as x. We have two equations, two variables, we can solve, provided that x is a univariate. Fx is a univariate function of x. Now if we consider that hx is also there, then we have one more multiplier for inequality constraints, which is mu. Then we call this is mu into hx. Now for handling this inequality constraint, apart from these two, that uh, derivative of this partial derivative of Lagrange function with respect to x at optimal is equals to 0, and partial derivative with respect to lambda at optimal is equals to 0. Apart from this, we have more conditions, which are the KKT conditions, which says that mu into h of x is equals to 0. So mu is 0, either hx is 0 or both of them are 0. Right? And hx is less than equals to 0. So these are the additional condition for inequality constraints. And mu is, one more condition is that mu is always positive. Here for equality constraint, lambda is a free variable. There is no constraint on the sign of lambda. It can be positive, negative, 0, anything. But mu has to be positive only. Okay, these are the additional constraints. Okay. We'll kick it now. We can answer this question with this background. KKT are used for to find the global maximum or minimum of a function, to handle inequality constraints in optimization problem, to check the optimality of a solution in the presence of constraints, and to determine the Lagrange function for each constraint. So KKT conditions are used, we already discussed that they are used to check the optimality of the solution in the presence of constraints. What is the main objective of a linear program? We have already discussed this basic framework. Minimize f of x with respect to x, subject to g of x is equals to 0, and h of x is less than equals to 0. We have this, right? When do we call it a linear program? When this objective function is linear. Next, and both these constraints are also linear. Everything, both the objective function and constraints are linear, so that becomes therefore it becomes an linear program. The objective is to find the optimal solution for a system of linear equation, to minimize the sum of squared residue in a regression model, to maximize the linear objective function subject to linear constraint, to balance the load and generation. This is our balance equation. And there are many many things in action which help us achieve this balance of load and generation in power system. It is not it is, yes, optimization is involved, but it has control also involved. Optimization will only give us an economic point. but the control will ensure that this is achieved. Because while optimization, several things, the dynamics is not considered. The dynamics is handled by the control part. The optimization will give us an economic or the optimal solution which is cost effective. But it is realized or materialized using control, only by control. Sometimes the optimization, the solution of optimal problem may not be realizable because of the approximation which goes into modeling the problem. Yeah, this is the correct answer. Then what is the purpose of NERC? Control performance standard in power sector. To enforce environmental regulation? No. To regulate pricing and trading of electricity in the market, to ensure reliability and stability of the system, to promote development and integration. This NERC is not an electric reliability council. They provide standards for reliability and stability of the system. So A is correct. Which characteristics is associated with the basic feasible solution in linear programming? Yeah, maximum objectively no. Feasibility is basic feasible solution has to do with the feasibility of the problem. Basic feasible solution requires feasibility of all the constraints. Which method is used to solve constraint optimization problems involving equality constraint? Simplex method is for LP. Here it is asking for any type of constraint optimization problem. Then Newton-Raphson and incremental heat rate method is not correct. Answer would be here Lagrange multiplier, right? We've already seen that it helps us to incorporate the equality and inequality constraints. Which characteristic describes the relationship between incremental heat input and power output of the steam turbine generator unit? It's the net heat rate characteristic, correct? Yeah. So let us move to the next one. Let A, B, C, and D be four matrices of dimension 10 cross 5, 5 cross 20, 20 cross 10, and 10 cross 5 respectively. You have to find out minimum number of scalar multiplication required to find the product ABCD using the basic matrix multiplication method. What we had seen this trick when we were solving this question in week 2 discussion. Here what we have to do, first of all, club those matrices which are having the higher dimension. First remove that higher dimension and keep on removing the higher dimension in the decreasing order, and then you will get the minimum matrix multiplication. Here is we see the maximum highest dimension is the 20, which belongs to these two matrices B and C. If we multiply these two, the final output will be 5 cross 10. Now, if we see, now we have to see highest common dimension, which is found here. Now, if you multiply these two, output will be 5 cross 5. Here it is 10 cross 5. Now this is the common. So here we get 10, finally we get a 10 cross 5 matrix. Here the number of multiplication required would be 10 into 5 into 5. 5 into 5 into 10, which is common. Okay, so this is 250. Number of multiplication now required for this part would be how much? 5 into 10 into 5, which is how much? Again 250, right? Am I making some mistake here? 5 into, oh, we missed this one, right? We missed this one. The multiplication required here would be how much? 5 into 10 into 20. This becomes 1000. And this is 25 into 250. The answer would be how much? 1500. Correct? This becomes 1500. Here multiplication is 5 into 10 into the common dimension. Then you have to multiply this and this. 5 into 5 into common is 10. Now multiply this to 10 into 5 into common. Okay. While solving the economic dispatch problem with using linear programming, increasing the number of segments in the approximated cost function brings the solution closer to the exact one. Not necessary. It depends upon the number of segments. Yes, we can compare 5 and 50. So 50 will be more closer, but we cannot say that 1, 2, 3, and 5. 1, 2. If we use 2 and 3, compare 2 and 3, it might happen that 3 can cause a solution which is away from the actual solution. Because it depends where it intersects. Like if we are doing this, these are 2. Here we have only 2 segments. If I find out 3, then it can be something like this. Okay. Now, if the solution is this, if I am on this point, and if we consider this 3 segment and 2 segment, then 2 segment solution for the 2 segments is closer to it is exact. But 3, if we solve it using 3 segments, then there is a difference. But yes, it is true that if we do it, compare it with between 5 and 50, then yes, 50 will certainly be much closer. And but in between there can be uh, up and down. It can be closer, or it can even cannot compare directly. Okay. The optimal economic dispatch is the best solution environmentally, not necessary. Because economic dispatch, we have seen what is the basic economic dispatch. We want to minimize the cost. Summation of CI PGI subject to PGI between PGI max and PGI min. And sum of PGI is equals to PL. Okay. This is the basic economic dispatch. Here we are only, this cost function is for the generation, not for emission. You can include that also, it will become multi-objective, but here this is nothing to do with the environmental aspect, emission aspect, because emission cost we are not considering, not factoring that into this formulation. The optimal economic solution may not always be best. Certainly it will not be. Then penalty factor in power system economic dispatch is a measure of line loss. These penalty factors are used for calculating the line loss, which is a function of the generation as well as the system network topology. In a two-plant system, the entire load is located at plant 2. We have this system like this. This is plant 2, this is plant 1. An entire load is located here. Plant 1 is supplying the supplying 100 megawatt of power with a transmission loss of 5 megawatt. Now we have to calculate the penalty factor of plant 1. Penalty factor, the loss function for plant 1 will be B11 P1 square plus in general it is this plus B22 into P2 square. But here this plant is directly supplying this load. There is no network involved here. This component and this component becomes 0. We have only one component, which is this. We are left with only one component, which is B11 P1 square. We know the loss is 5 megawatt P11 and P1 square. P1 is supplying 100 megawatt. We get B11 is equals to how much? 5 into 10 minus 4. Okay. And what is penalty factor? We know penalty factor is equals to 1 upon 1 minus dou P loss upon dou P 1 for generator 1. And we know loss function is this. Then dou P loss by dou P1 will be 2B11 P1, and which is equals to 2 into B11 is 5 into 10 to the minus 4, and P1 is 100. This becomes 10 to the power minus 2 into 10 to the power minus 1. This will be 1 minus 10 to the power minus 1.1, 1 divided by 0.9. This becomes 10 by 9. This is equal to 1.11. And the answer B will be correct here. Correct. Now the ratio of the maximum demand to the installed capacity. What is this ratio? Ratio of maximum demand. The one we know, load factor. Load factor we know it is. What is it? It is average upon peak. And this maximum demand to install capacity is a utilization factor. What is the penalty factor of a plant if it's incremental loss? Incremental loss means dou P loss upon dou P is equals to 0.2. Then penalty factor is equals to 1 divided by 1 minus 0.2. 1 divided by 0.8. which is equals to 10 by 4. Sorry, 5 by 4, 1.25. Correct answer is 1.25. Find out the piecewise linear cost characteristics for the following quadratic coefficient with the breakpoints as p is equals to 70, 100, 140, and 180. This is also a good, easy question. No, not that difficult. You have quadratic cost characteristics. It is between 50 and 200. Breakpoints are given as 70, 100, and 140 and 180 is also there. Have to make space for that. 140 and this is 180. Now, how many segments are there? 4 breakpoints means there are 5 segments. S11, let's say S1, S2, S3, S4, and S5. We have 6 breakpoints. 4 are these and 2 are these min and max. Total 6. 6 minus 1 slopes will be there. Total 5. Now we have to calculate each of these slopes, and we know that final P will be equals to P minimum plus associated with each segment we have one variable P1, P2, P3, P4, and P5. This is P1 into the P1 plus P2 plus P3 plus P4 plus P5. Okay. In each of these segments, P1 is between how much? P1 is between 0 to 20. The P2 length of P2 is 30. P3 is 40. And how much is P4? 20, 30, 40, 40 and 20. 40 and P5 is 20. And final FP will be equals to F of P minimum plus summation of S I PM. We can calculate it like this. Okay. Let's move quickly. A coal-fired thermal generating plant has 3 generating units having input-output characteristic and generating limits as mentioned below. Calculate the generation cost and incremental generation cost of the plant for a total demand of 400 megawatt. We have these 3 plants and we need to calculate the total load. Now we have the Lagrange function as P1, P2, P3 and lambda, which is equal to summation of Ci Pgi plus lambda times of summation of Pi minus Pm. correct? Now dou lambda by dou pi is equals to ci, this is pi square plus API square plus BI pi plus CI 2 AI pi plus BI, and dou lambda by dou lambda is summation of pi minus pi, and these are all equals to this is plus lambda also here. All this equals to 0. Okay. Now from here you can write pi is equals to can write pi, you can write it as minus lambda, or let us take this as plus pl minus lambda. This becomes minus lambda, and this becomes pi is equals to lambda minus bi by 2ai. You can substitute it here, lambda minus bi upon 2ai. This is the summation, which is equals to pl. From here we can find out lambda. Lambda, this becomes lambda minus summation of bi from summation of 2ai. Hence lambda is equal to pl plus summation of bi upon 2ai upon summation 1 upon 2ai. You can use this, and then pi you can find it as lambda minus 3ai upon 2ai. Using this, we have to find out lambda and pi. Then we have to check whether these pi are within the bounds or not. Let us see. Here we find out lambda and then calculate P1, P2, P3. Now we find that P1 is 190, which is within the bound. P2 is 90, which is also within the bound. And P3 is also within the bound. Directly we can substitute P1, P2, P3 here and calculate the total cost. Suppose if the PI, one of the generators goes out of the bound, then we bring it within the bound and then check. Just a minute. Yeah. Yeah, this is the next question. Here, I think we'll get into that difficulty. Here, something has changed. Only the limit has changed here. Limit here, P2 was 90.3. Now, limit of P2 has changed from 50. The lower limit has changed now. So P2 was between 50 and 100. Now it has P1 is between 100 and here P1 is between 100 and 300 and P2. Sorry. This should be P2 and P3. P2 is between 50 and 250. P3 between 40 and 350. Here P1 P2 range has been changed. It has reduced and this has increased. Now what will happen? Now because P1 is 190 and it cannot go beyond 150. If we make it at 150 and we make it at 100, we make P2 at 100. Now we make, first of all, these two generators are hitting their limits. One is hitting its maximum, one is below its minimum. First we have to satisfy the minimum one because generator cannot generate below minimum. Let us first fix the below the 100 limit. Now if we set it like this, P2 as 100 and P1 as 150. The remaining goes to P3, which is 150, which decides the lambda. Now based upon this 150, we can calculate the lambda. Lambda will be how much? 2ai Pi plus Bi. Now substitute this here. It becomes 2a3 P3 plus B3. And P3 here is 150. If we substitute this, we find out lambda 3 is 22.2 rupees per megawatt hour. Now again, we can find out the P1 and P2, lambda 1, lambda 2 also. Lambda 1 is this, lambda 2 is this. Now what should happen is that because lambda 1 has reached its maximum, that means its incremental cost should be less than the Lagrange multiplier, correct? We can see lambda 1, this is less than lambda 3, that means this is cheaper and we can load it to its maximum. Similarly, lambda 2 here, lambda 2 is reaching its minimum, that means it is the costliest and its incremental cost should be more than the lambda. But here it is less than lambda, that means P2 cannot be at its minimum. P2 should be above its minimum. So what we do, we fix P1 at 150, which is the cheapest, and then do the economic dispatch for the remaining two P2 and P3. So solve for P2 and P3 for a demand of 400 minus 150, which is 250. Now the new lambda is 20.45 and we can calculate. Which diagram represents the graphical representation of a power system showing the interconnection of buses, transmission lines, and generating unit? Yeah, it is the one line diagram, a single line diagram. What does the Newton-Raphson method applied to power flow equation aims to determine? Let me just connect the charger. Okay. What does aim to determine? What are we doing in power flow? What are we trying to calculate? In power flow, our goal is to calculate voltage magnitude and angle theta. Voltage magnitude and theta. Theta we need to find out at n minus 1 buses because for on the slack bus we have, for the reference bus we have theta is equals to 0. For other buses we don't know. We don't know this. This is n minus 1. And voltage magnitude we know for generator buses. We don't know for the PQ buses, which is n minus m, if m is the generator buses. Total unknown becomes 2n minus m minus 1. The aim is to find out the voltage magnitude and angle at each bus. What is the main purpose of Gauss-Seidel method in power flow analysis? To solve power flow equation iteratively, that is done by others also. To determine line flow and line losses, other PF also does that. The main part is to model the voltage dependent loads in power system. What does the term decoupled power flow refer to in power system analysis? We know the Jacobian when we make, there are these four dependency. Here we have unknown, which is, let's say this is voltage magnitude and angle is here. Then this is delta P. Decoupled power flow, we say that this dependency is not there. So power is active power is directly related to theta, and it depends on frequency, and reactive power is directly dependent upon the difference of the voltages. We say that these two submatrices are zero, and we are able to directly calculate theta from here, voltage from here. Size of Jacobian also reduces, and our computation also reduces. So it is technique to separate voltage and angle calculation in power flow. How is the economic dispatch problem with penalty factor different from one without penalty factor? Because it considers economic cost of power losses in system, includes additional constraint for environmental regulation, optimizes the power flow considering voltage dependent load, no. Accounts for coordination equation in power system operation, and considers economic cost of location line losses. What do you think is the correct answer here? This will come in hydrothermal scheduling potential equation. It considers the economic cost of power losses in the system. What does the reference bus penalty factor refers to in power system? The adjustment factor applied to generation cost and economic dispatch. What is the purpose of incidence matrix in power system analysis? To model transmission line flows and losses, calculate voltage and angle, to determine real and reactive injection? No. To represent connectivity in topology of power system. This is correct. Let's say we have this simple 3-bus system. Bus 1, bus 2, bus 3, 1 to 2, 1 to 3, and 2 to 3. And for building this incidence matrix, we need to make an assumption on the direction of power flow or the connectivity. We say that we generally consider this as, because line is connected between from bus and to bus. And generally the convention we take is that line is from bus to bus, and this from bus is lower index. and 2 bus we consider as the higher index. Now 1 to 2, this is lower index, right? 1 to 3, 1 is lower. 2 to 3, 2 is lower. So this becomes from bus. 1 to 2, 1 becomes from bus. 1 to 3, 1 becomes from bus. 2 to 3, 2 becomes from bus. Now incidence matrix. This is buses and these are lines. Line 1, line 2, line 3. Line 1, line 2, line 3. Now line 1 is connected between 1 to 2. It is leaving from 1, entering 2. So leaving we consider as positive. Then line 1, 2, 1, 3, 1, 0, minus 1, 2, 3. This becomes the incidence matrix, generally represented by A. In this, we have to calculate the line flows using a 100 MVA base. System base is 100 MVA. This becomes 2 per unit, 7 per unit, and 8 per unit. And the load becomes 1 per unit. Sorry, generation is total 9 per unit, and load also 9 per unit. This 1 per unit, 8 per unit, 2 per unit, and 7 per unit. Now we have already discussed this before. We have to make the matrices. Can use this method. Here we know that line flow is this, and voltage we are taking as 1 in DC power flow. That means it is, and because angles are, this difference is very close to 0, this becomes equals to delta n minus delta m. Flow becomes delta n minus delta m divided by XL. And this we can write in the form of a matrix, where this is a diagonal matrix, this is our incidence matrix, and this is the delta. Okay, diagonal matrix of this. It is 1 by x L1, 1 by x L2, 1 by x L3. This is diagonal matrix. Okay. And then power is B dash into delta. This B dash is the reduced susceptance matrix. Here we write B is this. A into B into. Now B, we know that B, what is the dimension of B? It is, what is B matrix? Dimension, it is n cross n. So this is n cross n. And A matrix is L cross n. This is, well, this is trans. We want n cross n. So this is L cross L BD, diagonal of is XL. We want n cross n. Here we want n cross L. This should be A transpose, right? And here we want L cross n. This should be A. Simply we can write A transpose into BD into A. Hello? Hello? I hope I'm audible. Just a minute. I have to take this call. Hello.
ఎరా బాబు ప్రాబ్లమేటిక్ సెషన్ పెట్టాడు కదా, నేను ఇప్పుడు జాయిన్ అయ్యాను. నేను ఒక్కడే ఉన్నాను దీంట్లో. నేను ఇప్పుడు వచ్చాను. ఇంక కాలు కూడా పెట్టుకోకుండా స్టార్ట్ చేద్దామని కూర్చుంటే ఎవడో లేడు.
Sorry for the disturbance. Yeah, I hope I'm
అదే కదా,
audible.
నాకు అదే బాధగా ఉంది. ఇప్పుడు నన్ను పట్టుకుంటాడేమో, నేను ఒక్కడే వచ్చాను అంతే.
We were discussing the questions of all the week which we had already discussed in each of the weeks.
ఏంటి క్వశ్చన్ ఆన్సర్స్?
I thought this would be the best way to summarize everything.
అవునవును.
Do you have any specific doubt in any
ఏమైంది
week you want to ask,
చెప్పరా?
or shall we continue with these discussing questions?
చెప్పే ఏమైంది? అంటే ఏమైనా ప్రాబ్లం అయిందా? మన ఎవడో బొబ్బా.
Yeah. Sorry.
సరే.
You were saying something? Hello. Shall we continue with this, or do you have any doubt?
కంటిన్యూ సార్.
Okay. I hope your doubt regarding this some anomalies in assignment 11 and 12, they were clear. Yeah, so we were discussing this question. Here we need to find out the line flows. So we can make this, we can use this. We know that flow is equals to difference of angle divided by the line impedance. And we can write it in the matrix form. So this is 1 by XL, and this is delta n minus delta m. And this is just a scalar. We can directly multiply it in the form of a diagonal matrix, 1 by x1, 1 by x2, and 1 by x3. And then we have to get this difference between n and m. For this, we use the incidence matrix, which is an L cross N matrix. For line 1, line 2, line 3, this shows us the connectivity with the buses. Line 1, this is line 1, this is line 2 and 3. This is between 1 and 2, and line 2 is between 1 and 3, and this is between 2 and 3. This is an L cross N matrix. And then we multiply it with the delta, which is a vector, which is a n cross 1 vector. Okay. Now from all this information, now A is a L cross N matrix, and diagonal matrix we have defined this is L cross L. From these two matrices, we can get B matrix. This B dash matrix, which we have. This B dash is the reduced susceptance matrix, and B is the full matrix. From these two information, we can calculate B, because B, we know that the size of B is an n cross n matrix. This is L cross L, and we want an n cross n matrix. For that, we need to multiply this by here L cross N and here N cross L. And we know that this dimension of A is L cross N. So this becomes A and this becomes A transpose. So B is equals to A transpose B into A. And this reduced susceptance matrix is the matrix by removing the row and column corresponding to the reference bus. Here if bus 1 is taken as a reference, then we can remove this first row and first column. Then we will be left with this 2 by 2 matrix, which will be this P dash matrix. And then delta will be a vector of 2 cross 1, delta 2 and delta 3. Same thing is done here. We have x1 2, x1 3 and x2 3. And we calculate the incidence matrix. D is the diagonal matrix. The B is A transpose D into A. And this B reduced acceptance matrix is by removing this first row and first column. We get this one. And now delta will be simply B inverse into P. And P, everything is in per unit here. So P is here. We are considering only this bus 2 and 3. So here P is net injection. So net injection here is 600 and base MVA is 100. So this becomes 6 per unit. Here net injection is into the bus, but this is a draw. It becomes negative. This becomes -8 per unit. So this is important. For load, we have to take minus. If this simple mistake, this one mistake will change the entire result. So this becomes 6 and this becomes -8. And just by taking the inverse, we can find out the delta. And flow, we have defined it like this. dA into delta. You can find out flow also. Right. So next question is, for neglecting economic dispatch. For economic dispatch that neglects the line loss but includes generation limits, what should be done if power is outside the limit of a generator? Then that generator will remain as participating generator. No, this will not be there. It should be set to the limit either at minimum maximum. Generator always be running at its rated power. These two are not correct. This is correct. And the generator is no longer a participating generator in optimization problem of dispatched power. So first we saw one problem also here, right? This one. This one. So here we see when we calculate lambda here for 3 generators, we get P1, P2, and P3 like this. Here we see P1, the bounds on P1 are like this. It is between 50 and 150. But here we see P1 is above its maximum limit. We will set it to its maximum limit. And P2 is below its minimum limit. We set both of them to 100 and 150 to their limits. Now only P3 remains, which is simply 150, difference of 400 minus 250. But now we have to check here the lambdas. If now, because these two are already fixed, this will decide the incremental cost. Now we calculate that incremental cost for generator 3, which is this. Now the solution is not complete. We have to check whether these two generators are satisfying this. Now, because P2 is at its minimum, that means it should be a costlier generator and its incremental cost should be higher than this one. That is why we don't want to satisfy demand from this generator. Similarly, P1, because it is at its maximum, which means that it is a cheaper generator and it has already been fully exhausted to satisfy the demand. We have to check that. For P1 is equals to 150, what is the incremental cost of P1? And for P2, what is the incremental cost? For P1, it is less than lambda 3, so this is correct. But for P2, it should be more than lambda 3 because it is costlier. But it is coming out to be less than lambda 3. That means P2 is not at its minimum. Our assumption was not correct. Now here you see that P1, we set this at its maximum limit, and then the remaining two generators, and this generator is set at set limit and it becomes out of the optimization problem. It is no longer participating in the optimization. Now these two generators will be optimized. Economic dispatch problem now becomes a problem for two generators with a reduced demand. A demand of only 250 because 150 is already supplied by P1. The same thing is argued here, and option B and D are correct here. Now, what are the techniques for solving the unit commitment problem? We have seen these methods, right? Priority list method we have seen. In the decreasing order of priority, we can do that. As the demand is decreasing, we can decommit one generator. And then dynamic programming also we have seen forward and backward dynamic programming, and Lagrange relaxation also is one of the method. We have already discussed in the sessions that Lagrange relaxation is a method for decomposition, for decomposing the problems into smaller, simpler problems. If we have one large problem, we decompose them into smaller problems, small, let's say n small problems. Each of these are very simple to solve, and then we solve them individually, and there is connection between these two problems. There is a master problem and a slave problem, and we connect these two. Then that is the main concept which is used in decomposition, and Lagrange relaxation is one of such methods. These are the three methods. And what are the thermal unit constraints? Minimum uptime is one constraint, because if a thermal generator is on for economic reasons, it has to be on for a certain duration. There is no maximum uptime, but there is a minimum uptime. And similarly, there is a minimum downtime also. Once it is out, once it is off, it will not come up for a certain duration of time, at least for that duration. There is a minimum downtime also associated with that, because it requires the heat thermal energy to reach a particular point where it can start generating, overcome the losses and everything, reach a stable value. For that, minimum downtime is also there. There is no maximum downtime, and there are crew constraints. These three are correct here. Minimum downtime constraint, we have discussed that. It means that unit cannot, that means it should remain on for a particular duration. Oh, sorry, it is minimum downtime. That means it cannot come up immediately. It should remain off for a minimum duration. Spinning reserve must be given percentage of forecasted peak demand, capable of making up the loss of most heavily spread around the system to avoid bottlenecks and sufficient for making a failure of a generating unit failure. So yes, we want to ensure that the system is running without any problem, even if there is n-1 contingency. That is, out of all the n components, even if one component fails, the system should be still working properly. Generally, we take the highest, the largest unit in the system, maybe 1 gigawatt, 2 gigawatt. Recently, there was one in UK. In past few months, there have been several cases, and UK there is also one interconnect, which is connecting UK with other country through North Sea. Ireland, I think. So there is that interconnect, which its capacity is more than gigawatt. I think it's 1.4 gigawatt or something. And that nuclear power plant which they have, that capacity of nuclear power plant is also above 1 gigawatt. So recently there had been this outage of this interconnect in one of the days and the outage of that nuclear power plant. So suddenly the frequency had dropped below the minimum permissible limit. They had to keep the reserves. Then the primary, secondary, and tertiary frequency response will come up and quickly try to bring the frequency back into the normal window. Similarly, this is on the negative side, that generation is not sufficient. And then the demand is there, generation is suddenly becoming, suddenly the generation gets less than the demand, then the frequency drops. But in this was case in Europe, but in India, there has been the opposite. Opposite case has been happening in the because of renewables in the daytime. And there has been a recent report on this also, that in daytime what was happening, because of renewable the generation was much more than the demand. The renewable was generating lot of quite large generation. It happens during this autumn, spring and autumn, because it's neither too cold, neither too hot, because both the scenarios are not good for, in both the scenarios, the output of wind and solar reduces. So there is temperature if it is too hot, then even neighborhood everywhere in the northern, in this Indian subcontinent, it's too hot everywhere. The wind is the differential, the pressure difference is less. The wind also, the wind speed is less in the subcontinent. Similarly, when it's too hot, the efficiency of solar panel reduces. So both the output of wind and solar reduces during very hot and cold climates. In cold, insolation is less, so solar output is less. The wind, same thing happens, pressure difference is less. If it is too cold. In monsoon season, wind is quite high. Wind speed is quite high. The solar output is very high during this spring and autumn season. In California, for last around 115 days, they have been operating the grid for at least 4-5 hours completely with renewables, wind, water, and solar. So because the generation is quite high than the demand, then the frequency goes beyond the maximum permissible limit. For several hours, it has happened, but it has been beyond the maximum limit even for 7 to 8 hours. So this has been happening. Just by this question of spinning reserve, this came into my mind. I just told this is whatever we are studying is actually happening. These are the challenges which the grid operators, Grid Control of India is facing, and other operators around the world are facing these problems. In strict priority order scheme, only combination for, so this is for the unit commitment. Priority order scheme. We make a scheme and based upon the demand. If demand is beyond this level, then all the units should be on. If it is lesser than these units, they slowly, as the demand keep reducing, one unit goes up. So options here are only the combination for n unit system, arranged in the order of full load average cost rate, and arranged in the order of minimum load average cost rate, arranged randomly. We have seen this, we have this cost characteristics for a generator, which is P minimum. It is between P minimum and P maximum. And if we calculate the incremental cost characteristic, it will be something like this. dF by dP. This is 2ai pi plus bi. Now we want to compare these generators, right? We want to arrange them in ascending, or because we want to reduce them, it should be in ascending order. When the demand is high, all the generators are on. When demand is less, only if it is very less, only one generator is supplying that. So that one generator has to be the cheapest one. And this should be the cheapest generator. Cheapest generator here and the costliest generator here. And till now we have been, this is also one of the new trend which we are seeing in Indian power system. You see, till now we have been, the operators or the what we call them, regional load dispatch centers or distribution companies, they have been using this term called merit order dispatch. Merit order. So they create on a monthly basis, these load dispatch center, they will create this merit order dispatch, and which is based upon this concept only. And based upon their variable cost, they will arrange the generators in the decreasing order, in the descending order of the the variable cost. And they have that list with them. And that is used to perform this kind of, I said, if the demand is minimum, then they will use the cheaper generators. As the demand increases, they will keep on adding, because they have that stack available with them. Which generator is the costliest and which one is the cheapest. It's easily available for Maharashtra. You can see, I have one of those. So it's available online. You can see for Maharashtra. You can go and check for Maharashtra merit MOD stack latest, something like that. You will find. You will see all the list of generators with in the decreasing order of their variable cost. Now here they will give you only one value of variable cost. How to find out that which we are saying, which one to take here? Here you see this is a line. It's a quadratic cost curve and its incremental cost is this line, which is this line. Now we have this line between P minimum and P maximum. Which value of incremental cost should be considered? This option B is saying we should take full load average cost rate. It is option C is saying the minimum load average cost rate. So which one to take? So this is, we take the full load average cost rate. And so this first we take this full load value. We calculate this. Calculate Fi Pi, the cost function. We have Ci Ei Pi square plus Bi Pi plus Ci. We calculate this cost, right? And then why is it called average? We divide it by the Pmax, install capacity. This becomes the full load average cost. It is normalized by the maximum, the install capacity. So we will get this one only, this cost. Okay. Here it is for combination of n system units, and the costs are arranged in decreasing order and of their full load average cost rate. High head plants are typically over 1,000 feet. In long-term forecasting of water resources, minimum duration of typical scheduling ranges how much? It is 12 months. Medium is more than 1 year. Medium is up to 1 year. Long term is more than 1 year. In short term hydro scheduling problem, it is solved by sorry. It is solved by lambda gamma iteration. In hydrothermal scheduling we have seen, as this we have discussed earlier also, minimize f of x subject to, we have this lambda and gamma represents what? Do you remember? What do they represent? We have this gx equality constraint and inequality constraint. Okay. So this lambda represents the dual variable corresponding to the equality constraint. In economic dispatch, we had only one dual variable because we had only one equality constraint, which was the satisfaction of, which was the power balance constraint. Summation of PGI is equals to PL. But here in hydrothermal, we have one more equality constraint, which is related to the water consumption, water balance equation. Inflow is equals to outflow. That equation is there. Or what if we are not taking inflow, then total discharge should be equals to capacity, which is there. These are the two equations that we have. For each of them, we have one dual variable. That's why it becomes, and these two equations are when we differentiate, when we write the Lagrange function, and we differentiate with respect to these two variables, the two equations which we get corresponding to the equality constraint, they are coordinated, they are linked with each other. One variable, both the variables appear in both the equations. Therefore, we cannot solve those two equations simultaneously. So we have to assume one value of lambda and solve these two equations. And then we get some optimal value for gamma. And again update lambda and keep on. So it becomes two for loops we have to use. One for lambda, one for gamma. It becomes a iterative procedure. Then Newton methods has a linear convergence. This is false because it has a quadratic convergence. Unit commitment using Lagrange relaxation is based upon dual optimization, primal optimization, or primal dual optimization. It is based upon dual optimization approach. Fuel scheduling problem is linear programming, mixed integer, linear or quadratic. It's a linear programming that we know. Size of Jacobian for n buses M generator system is, and we have n buses M generator. Now what are the unknowns? We have voltage, magnitude, and angle. Angle, except for the reference bus, we don't know. For reference bus, it is equal to 0. total n buses, unknown becomes theta becomes n minus 1, unknown theta. And how many voltages we need to calculate? Except for the generator bus, we need to calculate all the buses. N minus m generator. The total load buses, for all the load buses, we need to calculate voltage. So sum of them becomes 2n minus m minus 1. And Jacobian is a square matrix, no? The size becomes 2n minus m minus 1 cross 2n minus m minus 1. Okay. This question is based upon the Wooden-Woolenberg book, which we had discussed last time also. You can see the example in the book also. Because we are left with only half an hour, I will be skipping this problem. Let's see, let us cover first all the problem. We'll then take this one at the end. Because still there are total 100 questions and we have only come up to 45. What is the primary purpose of production cost model in the energy sector? It is to optimize the power generation schedule, right? So forecast energy demand is done by forecasting. The main objective is to optimize the power generation schedule. Which type of production cost program is commonly used for long-term programming? Which one do we use? It is a single area production cost model. Single area, we combine all the area. We assume that entire power system is brought into a single area. All these multiple areas are not considered to make the, because long-term programming problems are very large in size. We make these simplifying assumptions. Otherwise, it becomes too complicated and it becomes intractable. Even the existing solvers may not be able to solve them. That's why we make these simplifying assumptions, especially for the long-term planning problems, where the number of variables are very large, very large. What is the main use of long duration curve, load duration curve in the production cost model? To calculate transmission losses, to estimate energy demand variability. Load duration curve is used to optimize the generation unit commitment. It is same as what we are saying it. Priority list, if we say the demand is less, then the cheaper generator goes. If demand increases, number of generators increases. So this load duration curve will tell us for how much duration, how much is the demand. So the demand will determine which generator should be scheduled to optimize the generation unit commitment. Which method is used for computing probabilistic production costs considering unserved load? It is unserved load. It is unserved load method only. The demand not served. It is also called the demand not served method. So it's based upon convolution. It's based upon convolution of the outage PDF and the load PDF. The probabilistic load, we can consider Gaussian. Generally, Gaussian PDF is considered for the load. An outage PDF we consider as what we call uniform. And both of them we consider as discrete PDF. We consider the discrete distributions. So if we say this is the Gaussian load, then we discretize it. We have these 1.3, 4, and 5, 6 sigma. I take -3 sigma to +3 sigma. And we get this 7-point demand curve. For generator, the simplest model is two. Either it is out or it is outage is either it is outage is 0, that means it is operating at full capacity. Outage is 1, that means it is operating at 0, no output. These two we convolve. Okay. In the context of production cost program, what does the term expected cost refers to? Average cost of electricity generation, cost of unserved load. In the probabilistic analysis, cost of production considering load duration curve. It is the average cost. Expectation refers to in probability. This is the average. So this is the average cost of electricity generation. In the production cost program, what does the incremental cost data represent? This is what will be the cost for the incremental unit. Additional, what is the cost of generating additional energy per megawatt hour? This is same as that lambda, incremental cost, delta F by delta P. What is the significance of ordered list of loading segments in the production cost analysis? It optimizes it determines spinning reserve capacity, no transmission losses. It represents the incremental cost data and optimizes the unit commitment process. The ordered list represents this data only, and it helps us optimize the unit commitment process. What is the main purpose of expected cost method in production cost analysis? To calculate the expected energy demand, no, this is done by forecast. To calculate transmission losses, no. Cost of RE projects, no. Yeah, this is the answer to determine the average cost of electricity generation. And because we want to minimize the cost of generation and we plan everything based upon that only. 12, 20 years, 30 years ahead, we plan in such a way that the cost of electricity generation will be minimum and what resources are required to achieve that minimum cost. Now we have this storage coming up, different types of storage. We have renewable energy power plants. Now I want to plan for next 10 years. I want to meet the demand at minimum cost. Whether should I go for storage or should I go for wind plus storage, solar wind plus storage, or should I add a coal-based plant or a hydro? So this cost analysis is done, and which combination will give me the least cost. It will be expected cost because there are uncertainty involved. We don't know. There is even cost is unknown, demand is unknown. We don't know what will be the cost of storage after 10 years. We take different scenarios and take an average over those scenarios. That's why it becomes average, expected. What factor does the production cost analysis prioritize in determining the optimal generation schedule? Maximizing renewable integration, reducing transmission losses, and ensuring grid stability and reliability. Minimizing the generation cost is the factor. Production cost, Martin, you can see production cost. The production cost of what? It's the generation only. What is the primary purpose of interconnect and interchange in power system? To facilitate energy transaction between two power system. Which of the following is not an interchange category? We had discussed different types of interchange. Dynamic energy transaction, market-based transaction, these are different transaction. And interchange, in interchange, it is a powerful transaction. What type of transactions are involved in energy market? Spot market, dynamic, market-based transaction. All of these are available. Sorry, this should be spot market. What is locational margin pricing? This is also a very important concept. It determines the cost of transmission use based upon location. Because if we have this simple 3-bus system, let's say if we have sufficient generation and here is the load, the transmission line capacity is, let's say, unlimited. There is, or we can say the demand is less. So in that case, the transmission limits will not be violated any time. And this demand is easily met without any transmission violation. In that case, if we find out what in the economic dispatch we have seen, there is one equality constraint, which is the power balance constraint. Is equals to PL, right? This is only one equality constraint, and that gives us only one lambda for entire system. We can say this system is same as represented by this system. If there is only one lambda, that means all the buses are having same lambda and the load is being supplied and generation is able to satisfy the load. But if one of the transmission line is congested, its limit, then the power which was flowing from this generator to from this bus to this bus, and then it was rerouting as it was going like this and satisfying this load, that will not be possible here. Then what will this generator may, although let's say this generator was a cheaper generator and this was a costly generator, when there was no transmission constraint, this cheaper generator was able to satisfy the load. But now the power from this generator will not be, it will be limited, and this generator will supply more, which is the costlier generator. And because of that, this the incremental cost on this bus will increase. Initially, it was same on all the buses because there were no restriction, but now it will change on these buses. We will get one incremental cost for each of the buses, and we call them as location marginal pricing. Marginal price is incremental price, but we have added one more term, which is location, because it depends upon it depends on the bus, which part of the network the load is present, or which bus are we trying to monitor. Each bus it will change. Now there will be three such equation, three equality constraints, not just one. And for each of that constraint, we will get one Lagrange multiplier. We will get three Lagrange multiplier, and we call them location margin pricing 1, 2, and 3. Okay. So to cost the transmission use based on location. What is the main disadvantage of operating power pools? Limited transmission capability, lack of control over energy transaction. No, we are doing that. High cost associated with interchange. It is complex. There is a complex coordination and allocation process required. How are the savings allocated in a power pool? It is based upon, it is equally shared between suppliers and area. They saving full energy. What is the role of energy broker? To facilitate energy transaction between different power systems. What is the problem associated with parallel path in wheeling? Yes, it will result in inefficient transmission use. Because the power which was meant to flow from one bus to another, it is circulating within, creating transmission losses. And the transmission is being utilized for that internal loop, not for supplying. So the capacity is reduced. What is the purpose of identifying flow gates in power system? It is to calculate the total transfer capability. What is the role of spot market in power system? to facilitate energy transaction between buyers and sellers. The buyers and sellers will come, they will bid, the the buyers will bid, the sellers will offer, and then we get one intersection of these two curves, and we get a single market clearing price and volume. This is market clearing volume, this market clearing price. So all of the generators will receive this price. So what will happen? This generator, which is cheapest, will also receive this price. So this generator will be most profitable, right? And similarly, the demand, this this maybe distribution company was willing to pay such a high price, but it has to pay only this much. This discom is also benefited in that sense. Or maybe the discom was willing to pay, but now it has to pay less. Why this? But this would generally happen at such a high price. If discom is offering, that means the requirement of that energy is very important for the discom. Anyhow, the discom wants that energy to meet the load. It is willing to pay very high price also. In India, we have day-ahead market and we have real-time market. We have other markets also, intraday, and then term ahead market is also there. So in day-ahead market, there is a price cap of rupees 10 per kilowatt hour or rupees 10 per unit. Earlier it was 20, but now they have capped it to 10. And there are other high price day ahead market also. For that market, the minimum price is 10. So there are different products are there. Underground cable are usually a source of reactive power under usual loading. Yes, correct. They have high capacitance. The disadvantage of using a synchronous condenser is that it has a wide range of field control. No, it is not a disadvantage. False. Synchronous condenser increases the short circuit capacity of the system. Yes, that is true. Because it will reduce the overall impedance and then which will increase the capacity, short circuit capacity. Synchronous condenser can work as shunt reactor. Yes, it can operate both as a reactor and as a capacitor. When overexcited, synchronous machine works as a source of reactive power. Yes, underexcited, it becomes a sink. Overexcitation causes increased eddy current losses. No. There are some other problems associated with overexcitation. Hunting of synchronous machine may occur at light load due to low R/X ratio of the failure. No, it is not dependent upon R/X ratio. It is associated with that swing curve. Now this is one question. We will see. Okay. There is one formula for that. Directly we can use it and calculate. It's a 4-bus system. We have to find out the line outage distribution factor. For a 4-bus system, this is the slack bus. Bus 1 is the slack bus. Line impedances are given and maximum flow limit are also given. All are on 100 MV base. What is the value of LODF? So for this, we have to follow this procedure. So this, we convert everything in per unit and we have line impedances. First form the Y bus. We can easily form it, we know. And convert this into, this is 5 per unit minus J 5 per unit. Similarly, we can calculate this will be 1 by 0.258. Will be 4 per unit. And similarly, this will be 3.33. we can calculate each of them. Or this diagonal element will be summation of all this. And of diagonal element will be negative of this minus j5. So we can see a negative of minus j5 is plus j5. J is common. Similarly, we can calculate all the y bus elements. Now b naught is a minus times imaginary of y bus. So this is the same matrix which we also use in the DC power flow. We need this one, DC power flow. So this LODF and all these are based upon DC power flow because it is linear. We are able to use the principle of superposition. Now B dash reduced, same thing. We are using here. I think there is mistake here. This should be bus 2. Bus 2 is a slack bus here. Satisfy the reduced is after removing these two. The row and column corresponding to second bus. We can find out theta 1, theta 2, theta 3 by inverting this. P1, P2, P3 we know. Right. Now we have to calculate this. This is the formula XRS XLM. And X is, and this capital X, small x are the line impedance. And this capital X will come from this P dash inverse matrix, this. So this we had removed, this is 0. These terms are 0 corresponding to slack bus. And others are the elements of B inverse. And we can substitute all the values and calculate the LODF. So this is an important question. This you practice this. You can calculate for all the combination. Here we have asked only for 1, 2, 2, 3. This is next one is for 3, 4, 1, 4. You can calculate for all other lines also. You say SCADA measurement, SCADA based measurement can provide direct measurement of phase angle. No, that is false. PM you can do that. In SCADA measurement, we would get P, Q, and V magnitude. But in PMU based, we get voltage phasor, we get direct phasors and current phasors. We call them synchro phasors because they are time stamped and synchronized with the GPS clock. Calculate the inversion of gain is easier if direct inverse is taken rather than using numerical method. It is false. Direct inversion is never recommended. It is always costlier. Therefore, we use so many decomposition techniques to avoid this direct inversion and still calculate the inversion. Solve the equation. Expectation of measurement error is 0, true. Yes, we assume 0 mean Gaussian noise. Gaussian error. 0 mean noise in the error. 0 mean Gaussian noise. Now this is the point on 2D plot is given. Calculate the slope of. So this is a linear least square model fitting the model to the points. We will get one straight line to that point. So for this also you can directly you have the points and you can make you want to fit a equation. So y is equals to mx plus b, right? Now m and b you want to calculate, x and y you know. These are the x and y. You want to fit this. And so formula for that is you will get answer. You will be here your call. Let's say the unknown is represented by the vector z, which is m and b. So z will be a pseudo inverse of b. B here we call, these are the input. B will be input here. Let's say some B prime. Okay. So these are the input and A is the matrix which connect these two. M and B and X and Y. X and Y are the input here. So B will be represented by that. So this is pseudo inverse. A transpose A inverse into A transpose. Okay. Then calculate the expected value of X. We can easily do that. Sum 1 into 2, 2 into 4, 3 into 4 divided by total number of observations. You can calculate the mean value like that from histogram. If mu x and sigma x probability we have to find. And what is the probability? This is also simple. We know some standard probability and use them to convert this into standard form, the probabilities that we know, and just use those values to calculate the final value. Here, first of all, we normalize it because we know that what is the probability. We have a zero mean, and for this and standard deviation of 1, we know the probabilities for from 3 minus 3 to 3 sigma, what will be the probability? We know all those things. So we convert them into normal form. First normalize it. Then after normalizing, we get this. Now it becomes Z. It is 10 by 3. Z becomes minus 2 to 10 by 3. This is not correct. This should be 10 by 3 here. 10 by 3, sorry. This should be 9 by 3. This is 3. So this is equals to probability of minus 2 to 2 plus 2 to 3. This we already know. Plus 2 sigma to minus 2 sigma. And this we can write as probability of Z less than 3 minus probability of Z less than 2. This also we know. This comes from the CDF, cumulative probability, cumulative density function, CDF. And then we can calculate. S weightage is assigned to pseudo measurement, yes, because these are not the actual measurement, these are synthetic measurement. And we don't know how accurate these are. We are just using them to make the system observable and then calculate. A 4-pole 150 megawatt 14 kV 6S alternator has inertia constant. If the input is suddenly increased to 80 or a load of 60, the magnitude of acceleration of rotor is this. So we can simply calculate, use this equation and calculate. Sorry, I'm rushing very fast now. This time is almost over. And so I will upload this and you can go through them. Instead of downloading all the files, you can get everything in one file. Do you have any question?
Some of the questions, the explanation is not given, sir. But if you upload the video, how it is possible to go through that?
For which question you are saying?
No, generally, when you are explaining about this X value, expected value of X, like that, some problems are there.
Okay, yeah.
So those problems not written here. That's why even if you upload this video, proper explanation may not be get, because assignment solutions just ABCD, whatever is correct that you have given, but
Yes.
problem solution is not given.
Yeah,
We
that's
expect
why.
that in session we may get some idea about this.
So how means are these session helpful? Were you able to get the?
Yes, sir. This session is helpful. Actually, we expected that at least typed solution, if it is there, okay. Because anyway, time is limited for you.
Yes, yes.
Even
Correct.
when you are uploading it, some typed solution, if it is there, existing solution, we can go through that.
Okay, okay.
Some solutions you are writing, that's possible.
Yes. I will try to do that next time.
Yeah, at least some problems which you could not give the solution in the limited time, those problems at least focus and give some.
If you have some specific questions which you want answer for,
Yeah,
you
hydrothermal
can.
scheduling, you have shown one problem that we'll see at the end. Like that, some questions skip, no, sir.
So what you can do now, you can just mail me and the questions for which you want explanation. I will,
Okay.
because it will be difficult for me to do it for all the questions.
Yeah, yeah.
So you can mail me. I
Yeah,
will
you
just,
proceed. You proceed to complete this.
I will just, I will type my mail ID here
Okay.
in the chat box.
Sir, is there any possibility that I'm just asking these questions? Some questions may appear in the final examination.
That I don't know, but similar
Yeah,
questions, similar
similar
questions.
right?
Yes. Numerical questions will be very much similar to what we have discussed here. That's why I'm saying those questions which we have discussed here, like LODF calculation,
Yes.
line flow over that three bus system, all those are very simple questions. And if you practice, and
Yeah.
some silly
Take some
mistakes
time. You have
can,
to solve at the
yeah.
end, not at the beginning.
So you have to, yeah, try to solve the numerical before. First, try to solve the numericals because at the end we are in a rush and it's a general tendency to commit mistake when we are not focused. Means we are in the if we rush through, then it's difficult to the chances of making mistake is quite high. So here we are discussing probability. The probability of failure is high in that case. That's why it is recommended to solve the numerical questions first and then solve the other questions. It will. So those numerical question you can check. I think numerical questions for those solution is also available. If some problems it is not available, you just message me. Okay.
Okay.
Yeah. And in this file, most of the numerical questions are solved,
Okay.
which I am showing.
Right.
So you can go through all the numerical questions. If this is solved, and this is also solved. Here you have to find out the inverse Fourier transform. So just you can convert it into Laplace transform, replace j omega by s, and then take inverse Laplace. So you can go through. This question is also very simple. You want to find out the angle between successive PMU measurements in non-recursive. It is angle between two samples only. It is 360 divided by 50 samples. Then what was this in it is in this is a fact permissible synchronizing error for PMU for 60 Hz it is 0.0216 degrees. Class P PMU does not have
But its
anti-aliased.
slides are not moving, sir.
Lights are not moving.
Yeah, yeah. It is. You are at 80th question. It is showing here.
Oh, I'm on 84th.
Yeah. Yes.
Just a minute, just. Is it okay now?
No, sir. Actually, it is not in the slide mode.
Okay. Let me share again. I'll stop sharing. There's some problem with the laptop. It has stopped working.
You go to presentation mode, sir.
Actually,
Not in the presentation mode.
I've stopped sharing, but the laptop is hanged.
Okay.
Sorry. You want me to complete all the questions?
Actually, your target is 100 questions, sir. As per your list, sir.
I have considered all the questions which we had discussed in 12 weeks. So I had come in this presentation, all the 100 questions are there.
Actually, we can see 160 plus questions are here in the slide mode, whatever you are showing.
Where's slide? Which slide? Not 160, it is 103 only.
Actually, 162, 163 also I am observing here. Whatever it is.
Oh, oh. And I have in the slides 103 questions are there. Maybe slide number you are saying. Slide number will not.
Yeah, slide number,
No, slide number is not equal to number of
Yeah,
questions.
okay.
It's only 15 questions are left. For last, I think last 2 weeks are left. So then my laptop is not working. It is hanged. I'll have to restart it, I think. Still, it is not able to stop sharing. And now I think it's working. Can we take 2 minutes break?
Sure, sir. Okay, sir.
Yeah, I will just come back. Am I audible? Hello? Hello?
Yes, sir.
There is some, I will have to actually restart this. My system is, laptop is not working.
Yes, sir. Actually, it is showing only slides, not the slideshow.
Yes, yes. Even, sorry. Actually, it is hanged. I hope I am audible now.
No, sir. Your video is clear, but this
Am I audible?
yes, sir.
Can you see the slides now?
Yeah.
In slideshow mode?
Slide 95.
Yeah,
Go back,
sorry.
sir.
Sorry, there was some problem in the
Yeah, it
system.
is now working.
Yes,
Please go
yes.
to 80th slides.
80 question number 8. This was right.
80 is the last question discussed.
No, we had discussed this also.
Because that time it was not showing, sir.
Okay, okay. Yeah, we were on 84th.
Yeah, you start from 81, sir.
81. Yeah, this one.
Yes, sir. From this.
Yes. So this is the same simple question which
Yeah,
means we have to use this equation and everything is given. So we can directly find out the acceleration. Here we have to find the magnitude of acceleration and of the rotor. So we can use this equation. We have to find out this m first. So m we can find out using this and then calculate the acceleration. The next question is the Fourier transform. So here what we can do, here we can convert this into Laplace transform, replace j omega by s. Then it becomes a Laplace transform. Right? And then you can take the Laplace inverse of this. We can use partial fraction here and convert it into a by s plus 2 and b by s plus 4, because these are the two roots of this quadratic function. And then take the Laplace inverse, and at t is equals to 0, this will be 1, this will be 5 minus 1, so 4u0. Then we discuss this angle between successive PMU measurement. This is 2 pi by n. Angle between two successive measurements in non-recursive is 2 pi by n. And we want it in degrees, so multiply it by 100. So it becomes 360 by n direct.
Sir, in recursive, what is the formula, sir?
Recursive, angle is same, because what we are doing here, we are taking windows, right? Here, let's say this is the sample number 1, and in one window, which is one cycle, this is one cycle, right? Wait, in one window comprises of this one cycle. In one cycle, how many points we are considering? So that window here, let's say 20 points are there. So in this window, we have 20, n is equals to 20 for this window. Now, so for non-recursive, what we do, we calculate this and then we shift this window by one sample. Again, it is, now there are 20 samples in the window, starting from 2 to 21. Again, we calculate the DFT for these 20 samples. So we keep on doing it for each of the 20 samples. Every time calculate DFT again and again. This is non-recursive. Is it clear?
Yes, sir. Recursive, it is 0.
So in recursive, what we are doing, we are using the DFT which we have already calculated. We don't want to calculate the DFT again. So can we use the DFT calculated for the previous window to update the DFT for the new window? So here this DFT which we have calculated, now we want to, for 21st sample, right? What is the angle between these two samples? Can you tell? But the recursive formula, it uses the DFT of previous one and difference between this 21st sample and first sample. Okay, so n plus r minus r. R here is 1. N is 20. So n plus r minus r. Because in over n, it is 360 degree for n samples, right? So n plus r minus r will always be 360 degrees. It will always be 360 degree. And theta plus 360 degree is theta. Is it clear?
So in the assignment 10, this non-recursive actually 60 degrees given, but actually
60 degrees means 6 degrees.
n equal to 60 given, but the answer supposed to be 6 degree, but 7.2 is given.
So that n is not correct. Actually, it is calculated.
N is 50. If it is 50, okay, sir.
Yes. That so there is that mistake is there.
But nearby that value we have kept and we got answer anyway.
Okay. because other answers are quite far.
Yes.
Yeah, but correct is this. This
Yes.
is the way.
So for recursive, we have to do always 360 degrees only.
Okay. Yes, yes. Okay. So this is also done. Class P PMU does not have an anti-aliasing filter. Is this? So here we have two class. One is measurement class, one is protection class. In measurement class, we want accuracy. So we can afford some delay. In protection, we want fast, quick. So here we don't want delay, and filter will introduce delay. So this one is true, right? Because we want fast, so we can avoid this filter. This will not create much, will not result in much error. Is this okay? Recursive phasor update encounters problem of error propagation across all the windows. Yeah, this is correct. Because if there is error in the first window, because we are using that value for subsequent windows, all the values uh, will be having error in that case. The error will propagate throughout. Techniques for observability analysis, topological and numerical. So one is, and these are based upon linear algebra principles. And this is based upon network graph theory. So observability analysis, we want to see with the given number of PMUs, are we able to, can we measure all the states of the system? Can we measure everything from the entire system? Can we measure values at each bus with limited PMUs also? So that is done using observability analysis. If some of the measurements they even fail, can we do? Can we calculate the voltage and angle at that bus without that measurement also? In area 2, power system connected by tie line, if load changes in area 1, then the new tie line flow is influenced by the tie stiffness. No, because it is independent of the tie stiffness. A power system has two generating units, A and B, has a capacity of 300, B 200. Governor unit is, so this is gain R 0.1, B has 0.15. System demand is 400, frequency deviation is given. You have to calculate the change in load required from generation A to restore frequency to the nominal value. This is change in generation. So this is the relation between frequency and the droop. And delta P is delta F by R, the governor gain. And we know all these values, right? So you can calculate. So because this is in hertz and R is in per unit, so we have to use this frequency also in per unit. So divided by 60, then it will be in per unit. Multiply everything, you will get the change in generation required in per unit. Consider an AGC system with two control area 1 and 2. Area 1 has a governor time constant of 10 seconds and turbine constant of 5 seconds. Area 2 has governor time constant and turbine time constant. And the tie line constant is given. So we have a formula for this. Using this, you can calculate. Governor of 1 into turbine of 2 plus turbine of 2 into governor of 1. Is governor of divided by governor 1, governor 2 plus 2 times of tie line time constant. An isolated 50 Hz synchronous generator is rated at 15 megawatt, which is also the maximum continuous power limit. It is equipped with a speed governor 5%. Initially, generator is feeding 3 loads, and one of these load is programmed to trip if the frequency falls down. If additional load is connected, then what will frequency? It is same formula which we are using here. Delta F is droop divided by rated power and to change in power. So change in power is 3.5, droop is 5%, rated power is 15. So this is delta F. Now we can convert it into actual value. This is in percentage. So we find this is delta F in hertz and frequency is 49. The load is programmed to trip when it is below 48 hertz. So nothing will happen. The load will not trip. It will still be able to satisfy the increased load. This is very easy. P1 and P2 are given here in terms of frequency, and we have to find out the system frequency for total load of 400. P1 plus P2 is equals to 400. Everything is in terms of F, so we can directly calculate. It's one equation, one variable. Annual load duration curve of power system may be considered as a straight line from 40 to 80. Load factor. Load factor is average upon peak, and average you can calculate by these two, 48 by 2, 24. And peak load is 40, so it is very simple. Now, these two generators having 5% speed regulation rated at 200 and 300, and they want to satisfy total load of 400. We have to calculate PA by PB. We can use this. PA plus PB is 400, and we can write these two equations considering these similar triangles. These two triangles. One is this and one is this triangle. For each of the generators. So this divided by this is equals to this divided by this. So this is property of similar triangle. We are using these two equation. And then we can solve. You will get this PS 160, PBS 240. You can
Sir,
calculate.
there is one shortcut method for this. In the ratio of their ratings, they will share the load.
Yeah, because here
Speed regulation is same.
see, and no load frequency is also same. In this case, it will be simply 2 by 3.
Sir, in the assignment, question number 3, you said that different regulations are there. Actually, in the assignment, 4%, 5%. When we calculated, we got above 200 and above 300, more than their rating, above 200.
Yes.
But when economic dispatch is not considered in the load frequency problem, how can we consider that we should limit to 200? Should
Actually,
not take more than 200.
This is the technical constraint of generator. It actually this droop is
Actually,
very
when I asked the question in the question answers also, you have given me explanation. Okay, but along with the control problem, there should be some economic dispatch should be added. Then only that point will comes into picture, na sir.
actually this is not just economic dispatch because it is a technical constraint. This equation is only valid up to this point. After that, it is not even valid. So whatever we are calculating here, this is not valid only after 200 because this equation is not there. This equation is only up to this point. It is not applicable only. Beyond these 2 points, these equations are not valid. So this is a technical constraint.
But in the Nagardan Kothari, the same problem is there, sir.
Okay.
Even there also they have given PA and PB some 232 change and 369 change like that. That point is not considered in the textbook.
But we have to consider that.
Yes.
We have to consider that. And in that question, it was 4% and 5%.
Yeah.
So if we take 4%, because if we take two different groups, then it will result in that same thing, 200 above and 300 above. Above 200 and above 300. If we limit it to 200 and 300, then question is what is the frequency? Because one generator is operating at 4%, one is operating at 5%, both will give different frequency. What is the system frequency then? That's why the generator, we operate them on the same group. So if we consider 4%, then take both of them at 4%. Then one is 200, other will be, take 4% of this, you will get 320. It will be only 5 to 20. Okay.
Sir, your voice is not audible, sir. Hello, sir. Hello. Your voice is not audible, sir.
Mic is on. Can you hear me now?
Just now. Now it is audible, sir.
I don't know what was happening. Was mic was on.
Yeah, suddenly voice.
Yeah, so is this clear, this one?
Clear, sir, clear.
This was another question. You have to find out D on, it's here we are changing the changes by the frequency sensitive load changes by D is given here at 60 Hertz and on 500 kVA base. Now if we change the base to 1 MVA, what will be the new D? So change of the base here. So D will change because base is changing. In per unit it will change. Actual value will not change, but per unit value changes because the base value is changing. The same thing is done here because there is a change in the base value. This is changing. So this 0.1 is changed to 1. So are you able to do this one, this question?
Yes, sir. Yes, sir.
Okay. And now this is the last assignment. Were you able to solve this last assignment question? This was simple.
Yes, sir.
Right?
Yes, sir. I got 100%.
Okay, so let us move.
Sir, but for others' point of view, can you explain? Because they will see the recordings, no? That's why.
Okay. So this is simple because we have to calculate the total load current here. I think, can you explain this one? You will also, it will, and you will be revised. It will be revision for you. How to calculate this? How will you calculate the total load current here? Hello?
Sir, we'll take the wattage divided by power factor
Yes, yes.
and divided by that current.
Divided by
voltage.
which one? Which voltage? This one?
13.5.
Yeah. Yeah, so this is an approximation, right?
Yes, sir.
Yeah, this is approximate calculation. So first of all, get the apparent power. Active power is given. So S is P is S cos phi. Cos phi is known as we can find out as P by cos phi. Then we divide it by, because S is magnitude of S, which is complex power magnitude is apparent power, which is V into I. So I you can calculate by this. We'll calculate, we'll get current. Then next is total load current is already. Next is voltage. Then voltage will be, we can calculate delta V, which is I into Z, and R is given. So 0.14 multiplied by the length of the feeder, 1.5. Then multiplied by current, you will get change in voltage. Subtract it from the substation voltage. Then last, this is voltage regulation. So no load minus full load divided by full load. Sorry, no load. So you can calculate this also. Then last one is this power loss is I square into R. I have already calculated, R is given. So here you have to calculate it in watt per kilometer. So no need to multiply it by length. Directly calculate. This is point. Okay, the last, this one is this another question here. The total load is this 0.87 lag, and you want the power factor to be 0.9 lag, new power factor. So how much should be the, what should be the rating of the capacitor? So here this is a power triangle, right? Initially this was the Q1, Q which was supplied by the supply source side. Now you want it to be only this much, Q2. So the remaining difference between Q1 and Q2 need to be supplied by the capacitor, which we can simply find out like this. Q you can find out P10.5. So P10.51 minus P10.52, it is 0.825. This will be the rating. Because each capacitor is rated at 0.165, you can divide it. You will get 5 capacitors will be required. Okay, so which protocol is used for communication? In substation automation, it is IEC 61850. This one is used for synchrophasers. This is used for transmission IBR connection. Then this is used for DER integration into the grid. This is for transmission. This is for distribution. And isolated and non-isolated converters. So this buck boost and buck boost, these are non-isolated. There is no isolation between primary and secondary side. If there is fault on one side, it will propagate to the other side. So isolated are used, which are dual active bridge, full flyback and push pull. These are isolated. Another disadvantage of these non-isolated is that the gain which we get, the V output by V input, is maximum we can get up to 4. We cannot go beyond that. And if you want to go beyond that, you have to use isolated one. So it isolated provides isolation also and increased gain. Okay, so these are all the questions. Okay. Is it fine?
Yes, sir.
So we have discussed all the questions. So thank you for joining.
Sir, can you please write this code, sir, just with your writing? IEC 6150. Anyway, this is the answer. You said the orally, just you write.
Which one? This one?
Other protocols. That is for transmission. So transmission, like that you said. No,
yeah, this is for transmission.
Transmission. Okay.
This is for transmission renewable integration. Earlier it was not there. There were problems because people were using this DER interconnection for transmission system. They were using this standard at transmission level also. So there were many problems because of that. So they came up with a new standard for this transmission level, and this is for synchrophasers. And this is for this what we call substation automation. Okay.
Okay, sir.
Okay, so we'll close here. We'll close it here. Thank you
Okay,
for
thank you.
patiently waiting for such a long time.
Thank you, sir, for your delivery.
Okay. I wish you all the best for your exams.
Thank you, sir.
Okay. Thank you.
So you can get this video